All right, let's talk about a Linux distribution that has kind of quietly just taken over the whole world of containers and edge computing. I mean, it is tiny, it's incredibly fast, and it's built to be super secure. Yep, today we're diving into Alpine Linux.
So here's what we've got on tap. First up, what even is this minimalist powerhouse? Then we'll dig into its motto, small, simple, and secure. After that, we'll get into the big one, the great library debate. Then we'll see where Alpine is being used out in the wild. And we'll wrap it all up by talking about the fundamental trade-off you make when you go with Alpine. Okay, Section 1, a minimalist powerhouse. So what is Alpine Linux, really? What makes this OS the absolute go-to for developers who are obsessed with efficiency? Well, let's just start with the one thing everyone knows it for.
Yeah, you're seeing that right. Around 5 megabytes. The official Docker image for Alpine Linux is 5 megabytes. I mean, think about it. That's literally smaller than a lot of photos you've got on your phone right now. And just to put that in perspective, a minimal Ubuntu image, that's going to be at least 6 times bigger.
So yeah, this is the big question, right? How on earth do you get a full, functioning Linux OS into something that small? I mean, how is that even possible? It's not magic, but it is the result of some really, really smart and very deliberate engineering choices. And the official definition here gives us a few clues. You see words like independent, security-oriented, lightweight. This thing was purpose-built from the ground up for people who care about efficiency and security more than anything else. And the way it gets there is by using a totally different set of tools, a completely different software stack than what you'd find in, say, Debian or Ubuntu.
Which brings us perfectly to its core philosophy. Small, simple, secure. You know, this isn't just some catchy marketing slogan. It's really the mission statement that drives every single decision behind the OS. So let's break that down piece by piece. I mean, just look at this chart. It really makes it crystal clear, doesn't it? Alpine isn't just a little bit smaller. It's playing a completely different sport. And look, this isn't just about saving a few megabytes of disk space. In the cloud world, this means everything. It means faster downloads, containers that spin up in a flash, and, this is the big one, a much, much smaller surface area for attackers to target. So, what are the secret ingredients? How do they pull this off? Well, it really comes down to 2 key pieces of technology, musl libc and BusyBox. Basically, they threw out the standard heavy-duty toolbox that most Linux distros use. So instead of all the GNU utilities, Alpine uses BusyBox. You can think of BusyBox as like the Swiss Army knife of command line tools. It crams dozens of common commands into one single tiny executable. And instead of the standard C library, glibc, it uses something called musl libc, which was built from scratch to be as light and simple as possible. And this table just lays it all out. It shows you just how fundamentally different Alpine is. We're not just talking about the C library and core utilities. Look at the init system. It uses OpenRC, not the massive systemd. And its package manager? It's a super simple tool called APK, not apt. Every single one of these choices was made with one goal in mind: keep it simple, keep it minimal.
And that secure part of the motto? That's no accident either. I mean, first off, just by being so small, it has a tiny attack surface, right? Fewer packages means fewer places for vulnerabilities to hide. But it goes way beyond that. Everything in the system is compiled with modern security features turned on by default, like Position Independent Executables and stack smashing protection. These things are designed to just wipe out entire categories of common exploits before they can even happen.
Okay, but here's where things get interesting. Because Alpine's single greatest strength, that musl lib we mentioned, is also the source of its biggest headaches. This is the great debate. This is the trade-off that every single developer who thinks about using Alpine has to wrestle with. And this quote from a developer on Reddit just nails it. Unexpected weirdness. It's that feeling when you have software that runs perfectly fine on Ubuntu or Debian or whatever, and then you move it to an Alpine container and suddenly it just breaks. And not in an obvious way, but in these subtle, really hard to diagnose ways. And here's another person saying the same thing. At the end of the day, for a lot of teams, the time and effort spent chasing down these bugs just isn't worth the small image size. And the root cause, almost every single time, comes back to musl. So let's just lay it out side by side. On the one hand, you have glibc. It's what pretty much every other major distro uses. It's big, it's loaded with features, and it's super compatible. On the other hand, you have musl. It's tiny, it's clean, and it's extremely strict about following standards. But, and this is the big but, a huge amount of software out there was built assuming glibc and its specific quirks and extensions would be there. So when you try to run that same software on Alpine, weird things happen. You hit these infamous problems like DNS not working right inside Kubernetes, or your app randomly crashing because Muzz gives threads a smaller stack by default.
So with these pretty serious trade-offs, you might be wondering, why would anyone use this? Well, it turns out that for certain jobs, Alpine's strengths make it the absolute, undisputed king of the hill in some of the fastest-growing fields in all of tech. Just get a load of this. Even with all the potential musl issues, an estimated 20%, 1 in 5, of all containers on Docker Hub are based on Alpine. That is a staggering number. It just goes to show you that for containers, the benefits of efficiency and security are so huge that developers are willing to put in the work to deal with the trade-offs. And it's not just about Docker containers. Alpine is the perfect choice for any situation where resources are tight. We're talking about things like IoT gateways, maybe running on a little Raspberry Pi, or edge computing nodes that have to process data right where it's generated. You see it in smart cities and industrial equipment and all kinds of embedded systems. You know, these are the places where every single megabyte of RAM and every CPU cycle is precious. So here's what that looks like in the real world. A security-conscious developer uses Alpine to build these fortress-like containers. You start with that tiny base image, right? Then you only add the exact libraries your app needs, nothing else. You create a non-root user so your app isn't running with full privileges. You can scan it, use multi-stage builds to shrink it even more. You can even make the whole file system read-only. Now, these are all security best practices, but they are just so much easier to do when your starting point isn't a bloated 100-megabyte OS. All right, so let's bring it all together. After looking at the tech, the big debate, and where it's used, what's the takeaway? I think it's this. Choosing Alpine isn't about finding the one best Linux distribution. It's about picking the right tool for a very specific job. When it comes down to it, the choice is actually pretty simple. You choose Alpine when you are making a deliberate decision. You're saying, for this specific task, I care more about efficiency and security than I do about universal out-of-the-box compatibility. You're giving up the comfort of something like Debian for a tool that is absolutely perfectly optimized for one thing. It's a scalpel, not a Swiss Army knife, and it is an excellent scalpel. And that really leaves us with the big, fascinating question to chew on, doesn't it? The massive success of Alpine really makes you wonder. Maybe the future isn't about one-size-fits-all operating systems anymore. As our clouds get bigger and our devices get smaller and more numerous, maybe the future of the OS isn't generalization, but specialization. Maybe the future belongs to focused, purpose-built tools, just like Alpine.